Hello and welcome, my name is Tim and this is going to be my second tutorial for C#. In this tutorial I'm hoping to go through a rock, paper, scissors game, expand on the concepts that were covered in the first tutorial, a hello world equivalent. You can see the link below for further details. Anyway, I figured I'd start off first by showing you roughly the kind of application we're going to end up with. I'm going to be writing it again from scratch, so it may not be exactly the same, but I want to see the basic behaviour for the game. So open it up, and once again we have a console. I'm just going to hide OBS a second, and it basically just prompts you if you want to play rock, paper, scissors. So you've got a yes or no prompt, so let's go yes. And then it asks if you want to use rock, paper or scissors, reasonable enough, and then you pick one, so half of rock, and then it tells you the outcome of the game, and then you hit enter and it closes, and you can run it again, say no, and it just closes, and then you can also press a different key, and it closes, and you can go yes, and then give an invalid response for rock, paper, scissors, so Q, and it closes again. And then of course you can do paper, and you can lose, so there's an example of it winning and losing, so yes, it does actually work. Okay, so I think that's enough examples of what we're going to end up with, so let's get started. So, open up Visual Studio, file a new project, do another console app like we did last time, call this rock, paper, scissors version 1, and console app again, yep, take all the settings, seems reasonable, and hit OK. So once again we've got the default template that you get for the console app. So let's get rid of all the stuff we don't need at the moment. We don't need any arguments going into the program, so we can get rid of that as well. And then if you want to start off initially with that opening message of would you like to play, so do control right line, control, no, this is where you have to do our first import because I removed them all. So it's import system.console. That brings back the first using statement. So let's do control right line, would you like to play rock, paper, scissors? Right, so then the next thing you want to do is get the user input. So for that you want to use console.read key, and then you want to get the value from that and store it in variable. So let's go var user input, let's put the prompt so that the user knows to put a yes or a y or a no, so yes or no, so they have any idea what to press. That'd be useful. And then you can do a simple check. So this is the first time I've done an if statement. So an if statement is basically conditional logic. So it's a simple, if statement is true, do this. Alternatively, you can do something else. So the formatting is a true-false statement or Boolean statement. So in this case, let's go user input is equal to user input key dot y. Oh, there we are. Right. And then open and close. I think I missed a bracket. Here we are. No. I've got 1 2 minutes. There we are. There we are. So if we want to play, then the game will continue. So we'll do console.writeLine. Would you like to use a rock, paper, or scissors? And if that's not the case, we'd get a return. It's not strictly needed because this is the main subroutine, and when the main subroutine finishes and there's nothing else, the program closes anyway. But I just wanted to introduce you to the return as well. So, assuming that the player picks yes and wants to continue, we now need to get the choice that they're making of rock, paper, or scissors. So we can just copy this again and then just do choice of item. There's a choice of item. There you go. Let's go with choice of item. So now that we have that, we now need to have the computer's version. So for the computer, let's just do. We want to have a random option of rock, paper, or scissors. So to help with that, we've got a class called random. Let's call it random gen. You create a copy of random, and then you have to pass in an initial seed because random on a computer is not strictly random, so it's just pseudo random. So to help make it closer to random, you can do contains a seed to something that changes constantly. So you can go new date time. Oh, is it actually it's date time, isn't it? Date time dot now dot milliseconds. So what this is a representation of current time, and then grabs the millisecond. So because every time you run this program, the millisecond will be different, you'll get a different seed going into the random generator. So now that you've got the random generator, you go random generator next, so it returns the next integer, so a whole number, and let's pick between 1 and 3, so 1 is rock, for instance, 2 could be paper and 3 could be scissors. And then we want to store that value, so let's put that in an integer, and call it computer choice. So now we've got the player's choice and the computer's choice. We now need to do all the checks for if, I have rock and they have paper, that I lose. If I have rock and they have scissors, I win, and so forth. So for that, it may be a bit easier from a readability point of view to use what's known as an enumeration. So enumeration is up here. It's basically a list of strings, but they can represent numbers. So we can say, let's call this enumeration rock, paper, scissors, and then so we have rock, paper, and scissors. Oops, if I can type, there we are. And then if I mouse over here, you'll see that it assigns the first entry in the enumeration 0, paper 1, and scissors. So this allows us to then go. Well, first off, we can then change this from so rock, paper, scissors, and then go it's a random number, and then actually I think I'm covering too many concepts too quickly. So this will allow you to improve the readability, but we now need to convert the integer into the enumeration. So to do that, you can go rock, paper, scissors, and put it in brackets, which is a cast. And then computer choice, like so. And then we put that up here instead. Go for computer too. Here we are. Always a copy paste. God, right. This is what I'm doing in real time. It's always mildly entertaining. Right, there we are. Give it the extra bracket. So now instead of this being enter, you can see it's now rock, paper, scissors, and then we can do the same for the player eventually once we've converted from what they've typed as rock, paper, scissors into another version of the rock, paper, scissors enumeration. So to do that, we can use what's known as a switch statement. So we can switch on the choice of item, and basically what this means is that it will look at the value of this, and then you can specify different behaviors to run in different scenarios, or as it's commonly referred to in this as a case. So in the case in which choice of item is equal to R or key dot console key dot R, then we can go we need to make it a variable for the players, so let's go rock, paper, scissors, players, ultimate choice. I don't even know what I typed over. That's because I was thinking player and I typed paper. Oh dear, right, okay. Player's choice is equal to rock, like so. And then you add a break statement. So then you can do another case. So I'll continue writing these out, and then I will go into a bit more detail as to what it's doing. So scissors, console key, scissors. Let's just do some copy pasting here, I think. Otherwise it's going to take far too long. Case, console key, dot p. That was paper, and that's scissors. There we go. So this saying that it will then, so we are reading the key that the player places, and then we then get the specific key and check it against types of key. So if it's R, we then give the player the rock. If it's S, we give them the scissors. And if it's paper, we give. If it's P, we give them. Oh, what have I forgotten? Oh, I've forgotten the break. There we are. So the reason the break exists is where it differs from an if. Is if in a switch you can have one scenario and it will continue. You can have multiple scenarios. So the idea is that you break to stop it from running further. So you hit the first one and then stop. So it falls through essentially. And then the other. So now that we've got the player's choice in the form of a rock, paper, scissors enumeration, and we've got the computer's choice, that's the same thing. We can then do the checks for who won and who lost. So one of the things I realised when I was doing this in the earlier example and helped to simplify logic is if you do this so that the rock, for the rock last, like that, then you can say, because it gives you the order of 0, 1, 2, that the scissors is 1, which can be greater than 0, so you can just basically essentially say that the large number beats the previous one. So rock will be scissors and scissors will be paper. That just helps simplify the logic a bit. There probably is a better way off the top of my head, but that's what I came up with on the spur of the moment when I thought of doing this tutorial. So we can then do if player's ultimate choice is greater than computer's choice, then console dot right key of U1. No, so it's not what it says. So this is the issue, is that with enumeration you need to set a default value. So I'm going to put in a undeclared version so that we can say that the default is going to be unassigned, so you've not made your choice yet, and that will eventually lead into error handling later on as well. So undeclared, there we are. So as long as the player's choice is greater than the computer's choice, you win. So yep, that's fine, except for paper. So now that's where we need to do a bit more logic. So if player's ultimate choice is equal to rock and the AI's computer choice is equal to paper, then you lose, obviously. Right. Else you won. So in this case, if you pick any number bigger by default, then you'd win because that's the order that it works. The only case that's not true is when you've got rock and the computer has paper, in which case you lose. If that doesn't happen, then you've won by default as part of this if statement. So if this is true, run this. If not, runs this. And and then you've got else. So if you're not begin, then you would typically have lost. Now that doesn't quite cover all the scenarios, because you've got the scenario in this case where you've possibly put in an invalid key earlier. So if you typed like a Q, then you've not picked it. So to add for those extra scenarios, you've got the option of an else if. So it just lets you do another check essentially. So let's do else if the player's ultimate choice is equal to rock paper scissors undeclared, then then you lose by default. And I'm thinking there's that FB scenario. Oh, and the other thing we want to put in is the console dot read keys. So this is so that when it runs, it doesn't instantly just close like we did. So it's exactly like the hello world example. Let's put those all in. And I'm sure I would have forgotten something, but we'll have a look. Let's set 5 and see how it happens. So we've got what maybe it is. So let's go no. It closes. Okay, that matches what we were trying to get to. Let's try yes. Would you like to use rock paper scissors? Okay. So first spot is that this is on the same line as the previous thing. So that doesn't look very nice, does it? So to solve that problem, you want to put a new line character at the front of your thing. So to do that, you can do \n at the beginning. So if you put that in front all the times you're asking for instructions, then it will look slightly cleaner. Like so. There we are. Okay, so we probably don't want it on the first one. So let's quickly fix that. There we are. Okay, so then we can go yes, and I'd like to use rock, and we lose. So that's not particularly, doesn't tell me what the AI used or the computer used, and we have no way of checking if I've maybe potentially missed some logic here. So let's add some information to the scenario that's occurring. So for that you can use an interpolated string. So that's basically when you put a $sign in front, and this essentially lets you type text like you would normally, but then you can add the values from your variables straight into the string using these squiggly brackets. I have no idea what they're called, but then you can reference the variables from earlier. So in this case, you can go, you lose. So you lose when you played player's ultimate choice against computer's choice. Right. So something along those lines. So then if we do that again, so because I'm lazy, I'm going to copy paste this. Oops. There we are. So you won when you played against, right? And let's get right, there we are. So now we should hopefully get some information when it runs through. So have a look, see? Yes. Rock. So you played rock against. Yep, that looks okay. Let's run it a few more times. Pick paper. You lose when you play paper against paper. Well, that's not right. So yes, I've forgotten the draw scenario. So for that we can go else if player's ultimate choice is equal to, so computer's choice. So when you're doing a comparison of values, you do a double equals, whereas a single equals is for assignment. So in this case we go console dot right line. In fact, let's copy this again. So because we're going to want the information given to the user. So the game ended in a draw when you played against area. So that should hopefully cover every side. So let's test this a little bit. Well, you played rock against paper and I lost. I played paper against scissors and I lost. Seemed okay. And scissors. Ooh, that ended very properly. Ah, forgot the console key here, so that was probably a draw. Right. So I won when I played scissors against paper. Okay, so that's a 1. Brilliant. And that's pretty much the application. I hope you found this useful. I know we covered quite a few concepts, and I might have just brushed over a few of them in possibly not enough detail. But if anyone has any questions or concerns or wants to know information for you, please let me know, and I'll happily do a follow-up video on that specifically. Well, I thought this might be a little bit more exciting than a Hello World, and it gives you something tangible to show off, or show someone who's saying, yes, I'm learning programming, so here's this little thing. Hope you enjoyed it, and I hope to see you next time. Thank you, and goodbye.